Okay, so I'm going to do the short questions from the sheet that I gave you. I'm going to try to get question 1 to 10-ish done in this video, and then hopefully 11 to 20 in another video if you required. So the first thing is question 1, simplify root 5 minus 2 on 3 root 5 minus plus 6. Bracket on bracket, what you generally do, split your brackets, no different here. So you're going to have root 5 on 3 root 5 plus 6 minus 2 on 3 root 5 minus 6. Right, just ignore the fact if the writing gets messy in this or if it starts to act up a bit. Right, so into your calculator you're going to put root 5 by 3 root 5. That's just going to give you 15. Your calculator will do that for you. Plus 6 by root 5 will give you 6 root 5. Minus 2 by 3 root 5 will give you minus 6 root 5. Minus 2 by plus 6 will give you minus 12. So you're going to have 15. The 6 root 5 minus 6 root 5 cancel out each other. So your answer is 3. Very easy. So bracket on bracket you just split it like normal. So express 3 to 9 in the form a by 10 to power n to 3 significant figures. Okay, so you put 3 to 9 into your calculator. 3 to the power 9 you're going to get 19683. First thing you do is you put in your dot. Then it's 3 significant figures measured using 3 digits. So it's 1.9. The 6 will round up to 7 because of the 8 by 10 to the power of how many spaces are behind that dot? 4. So that's it in scientific form or standard form. Question 3. So solve to one decimal place. So what you have to do is you have to get common denominator. Common denominator goes in the bottom, so your common denominator is all the bottom parts. 2x plus 1 on 2. So first off we're going to say the first part, so 2 is the first thing, because that was here. So underneath 2 we have 3x minus 4, so 3x minus 4 into this whole common denominator will leave us with 2x plus 1 on 2. So you just really ignore the one that was just underneath. So minus 1 is next then. So 2x plus 1 into the common denominator goes 3x minus 4 times on 2 equals 2 into common denominator goes 1 on 3x minus 4 on 2x plus 1. Right, so then we're going to have 2x plus 1. I don't know why that won't work there. So what I generally do is multiply them two by each other first. So 4 on 2x plus 1 minus 2 on minus 1 minus 2 on 3x minus 4. If you want to do it out a bit longer, that's okay. So 2, here we have 2. The 1 isn't going to affect this, so it's 2 brackets on each other, so it's going to split your brackets. 3x and 2x plus 1 minus 4 on 2x plus 1. At this stage, because it's your common denominator, as there's an equals in it, you can forget about your common denominator at this stage. So if, say, the sum was just this part here, so you never had the equals a half, and it should simplify, then you would keep it in fraction form, you keep your common denominator. But if they said to solve, once there's an equals in it, that means once you've worked out your common denominator and you've done the multiplications necessary, like just here and here, you can dump your common denominator, forget about it. So this gives 8x plus 4 minus 6x plus 8 equals 6x plus 6x squared, plus 3x. Minus 8x minus 4. Okay, as you can see, you're going to get some sort of quadratic, so we'll tidy it up a bit. So 2x plus 12 equals 6x squared minus 5x minus 4. Bring them all to one side. 6x squared minus 5x. The 2x becomes minus 2x minus 4. The 12 becomes minus 12. Let it all equal 0. 6x squared minus 7x minus 16 equals 0. What do we have here? An x squared, an x, and a number. Therefore, we're going to open our brackets or use our minus b formula. If we use a minus b formula, it would be easier because the numbers are so big. So a would be equal to 6, b would be equal to minus 7, and c would be equal to minus 16. My pen's not working here at the minute. I'm not going to do it with the minus b formula because everyone should know how to do that at that stage. Just remember that when you're subbing in a value, you put it in a bracket, so you cannot make a mistake, and it's so important that people make that mistake so often. So like for instance, the minus b plus or minus square root b squared is going to be minus 7 plus or minus the square root of minus 7 all squared, so that will give us plus 49. And the minus 7 at the beginning will give us plus 7. So it'll be 7 plus or minus square root of 49 minus 4 times 6 times minus 16, and so on. Okay, so just your minus b for memory. Right, we'll just talk about the next question. So question 6, verify that minus 2 is a root of the equation. If you want to verify that something is a root, you literally just sub it in. So every time we have x, we're letting x equal minus 2. So anytime we have x, we see x, we sub in minus 2. And what should happen there is we'll have 2 on minus 2 cubed plus minus 2 squared minus 10 on minus 2 minus 8 equals 0. That will give us, what will be minus 16 plus 4 minus 20, or plus 20 minus 8, that'd be 24 minus 24 equals 0, that'd be 0 equals 0, therefore, because 0 equals 0, it's a root, so I'm not going to bother doing that one out for you, so you just sub in, so it'd be 2 on minus 2 cubed, blah blah blah, sub it in, to get 0 equals 0, it's a root. Roots of, the roots are 3 and minus 2, find the equation. Okay, this could be given to you in a graph, they could just have it going through 3 and going through minus 2. Should literally give it to you like that and say find the equation of that graph. Well, you know x equals 3 and you know x equals minus 2. They gave it to you in the question or by the graph, you could see that. Make your roots factors. So bring your x across the equals, put it back into its brackets, so it becomes x minus 3 and x plus 2. So as you can see, the sign changed. 2 brackets on each other, you split your brackets. X squared plus 2x minus 3x minus 6, x squared minus x minus 6 equals 0. There's your equation. Simple. What's a prime number? Prime number is a number that can be divided by itself and 1, so 1 is not a prime number. So we have 2, 3, 5, 7, 11, 13 and so on. Prime factors, so you press 5A5 into your calculator, press equals, then shift, and then fact, and it'll come up. If you can't remember how to do that, just divide by prime numbers until you get 1. So 1, 1, 7. 3 times 39, 3 equals 1, 3. 13 is prime number, so we got 1, so that would be 3 squared by 5 by 13. Your calculator should tell you that anyway. 1365, same thing, divide by 5, so 3, not 1, sorry, what is that number, 273, 3 goes in 91 times, 7 goes in 13 times, 13 go in once, so 3 by 5 by 7 by 13. The highest common factor of these will be what's common between both, so 3 by 5 by 13, and into your calculator and whatever that gives you. I don't have my calculator with me today. The lowest common multiple will be you put in everything but you repeat nothing twice, so we'll take the 3 squared here, meaning that we won't take it from here, the 5 from here, meaning that we don't need to take it from here, the 13 from here, meaning we don't need to take it from there, and the 7 from here. So your lowest common multiple is always going to be your longer one. So that's 3 squared by 5 by 7 by 13. Put it into your calculator and it'll give you the answer. I don't know if they'll come up. The factorial prime factor might, but you see the HCF and the LCM isn't in any of the books bar active math, so I'd be very surprised if it did make an appearance. But indices to the power, so get your bases to the same power, so 2 to the power 3 is going to be that. Then you're going to open up your log tables, you're going to look at your rules. You'll see a rule like this and it multiplies them too, so it's 2, 3x equals 2 and x plus 4. Once your bases are the same, they cancel, so you have 3x equals x plus 4. 3x minus x equals 4, so 2x equals 4, x equals 4 over 2, x equals 2. Really easy.